Everyone, this is Harni Gangapuram. I'm here with my team to explain about our project that is forest fire prevention using logistic regression. The name itself says that to prevent it, first of all, we have to predict the fire occurrence in the forest. So, to prevent it, we want to use this logistic regression. Just see what is the problem. So, here the problem is we just identified a problem, that is, first of all, let's think of the forest is the one which is a resource for many species on the earth, such as shelter for wild animals, birds to get prevented from the extraction of materials such as wood, livelihood can be found by the humans, such as getting fruits, vegetables, materials. As we discussed, by acquiring all these things, profit can be gained. If people consider these as business, forests provide all these resources to each and every species on the earth. Humans are the one who takes the major part in usage of forest, because forest plays a major key role in the human survival as we discussed, but simultaneously humans are taking part in the destruction of the forest. Let's get to know some types of destructions: deforestation, pollution, plastic usage, global warming.
Coming to the motivation, due to the occurrence of fire in the forest, it affects the animal's survival. It leads to the extinction of some species such as birds, destruction of medical plants, economy loss, and it affects the ecosystem. We could define the above outcomes as the objective of the problem.
Now, let me explain you about the proposed plan. Our project Forest Fire Protection is based on machine learning algorithm. It is basically used to predict whether there is a chance of occurrence of fire in the forest or not. We will be predicting the occurrence of fire in the forest by using the three parameters. One is oxygen, humidity and temperature. Based on these three parameters taken as input from the user, we will be predicting whether there is a chance of occurrence of fire in the forest or not. First thing, let us consider three scenarios in this. When the oxygen level is too high and the as oxygen is good conductor of heat, there is a high probability of occurrence of forest fire in the forest. And second thing is that if the temperatures are too high and oxygen level is moderate, even in such cases there is a high chance of occurrence of forest fire. And third thing is that when the humidity levels are high with the moderate levels of temperature and oxygen, in such cases the occurrence of forest fire is low, because humidity is contains the water molecules which reduce the temperature and thus reduce the occurrence of forest fire. In order to take these three parameter values, we have created a interface for the user where they need to provide the humidity, temperature and oxygen levels at that particular point of time. By considering these three parameters in the background, we will be running the logistic regression, and the output which is provided as the whether there is a occurrence of forest fire or not. If there is a occurrence, what is the its probability? Thank you.
Now let us discuss about the data set. In our project, we need an efficient data for training and testing purpose. The data set that usually used in the project contain four attributes. Those are area particulars. Other three main parameters which consider as deciding factors, that are temperature, humidity and oxygen. And the last tuple in the output which predicts whether the forest is in danger or not, and it is in the zero or format, that is in the binary form. Now we are going to discuss about how the factors affect the fire. If the oxygen is high, it is favorable to fire. If the temperature is high, so this refer to heat, it is favorable to fire. If humidity is high, it is unfavorable to fire. According to the above cases, probability of occurrence of fire and also prediction can be done. This kind of model is essential in maintaining sustainability and also in reduction of deforestation, along also in extinction of animals. Now we are discussing about data visualization. In data visualization, we have plotted the line plot, bar plot, scatter plot, and also the heat plot.
I'm going to discuss about proposed approach versus existing approach. In proposed approach, we had supervised algorithms, which are used for making predictions by learning from historical data. Whereas in existing approach, we had empirical indicators. Here, predictions are based on real world indicators, which can be data driven but may lack the sophistication of advanced algorithms. In our proposed approach, we had probabilistic forecasts. This approach involves generating forecasts based on probability, offering a range of possible outcomes. Whereas in existing approach, it had weather forecasts. It used weather forecasts. Weather data can be updated regularly to improve predictions. In proposed approach, we have hand-drawn billboard, which is a creative non-digital method to raise awareness about wildfire prevention. Whereas in existing approach, it had predictive determinism. That approach assumes that predictions are more rigid and deterministic, relying less on probabilistic uncertainty. In proposed approach, we have higher accuracy. This approach is expected to yield more precise predictions, whereas in existing it had lower accuracy. That approach is likely to be less accurate due to the absence of advanced forecasting techniques. In summary, the proposed approach focuses on advanced predictive techniques and probabilistic methods for higher accuracy, while the existing approach is more deterministic, relying on empirical indicators and weather forecasts, but may not be as accurate. Thank you.
Now we are going to discuss about the how why we use Flask in our project. Flask is a lightweight Python web framework that allows developers to quickly build web-based applications. In forest fire protection, these applications must include like dashboards to monitor fire risk in real times and APIs to serve predictions fire alerts or sensor data to other systems or applications, and most importantly user interface for users like forest emergency problems or in danger to interact with the systems. So we can see that model that we use it in logistic regression model to render the dynamic web pages. We use Flask, which is a micro framework. It allows only required components and it uses it to render the dynamic web page and allow or pass the data to the front end. Here the data such as prediction result.
Now let's discuss about the logistic regression. Logistic regression is the model that we used to deploy our project. So logistic regression is a statistical method used in machine learning for binary classification problems. That is situations where there are only two possible outcomes like yes or no. Fire or no fire are safe or dangerous. Despite its name, logistic regression is a classification algorithm, not a regression algorithm. And now let's see how this model works. First, we have to give the inputs from the user interface to the Flask. That will be sent to the Flask file by using the post request. And then Flask file loads the model which is already pre-trained. And then it considers the inputs, and also by using the logistic regression model, it predicts the output. And that message is rendered to the dynamic web page onto the user interface. By clicking this output button, this process will be done, and then the output will be displayed as forest is in danger, probability of occurrence of fire according to the inputs. Then now this would be the block diagram of the model, and then this is the implementation. The requirements are VS Code, command prompt, Python Flask, the virtual environment, and this must be created in the folder where we are just working on our project. And then this is the HTML file we created by using the HTML, CSS, and JavaScript with the parameters such as temperature, oxygen, humidity. When you click the button predict probability, predict probability, the output is displayed. And then these are the libraries that we have used: NumPy, Pandas, SQL, and linear model. And by this, logistic regression will be imported, and the train test split will be imported from SQL and model selection, and also joblib we use instead of pickle. And then this is the training and testing the data splitting. So here we train and test the data, and the data is split into two parts. That is the train size, that is 0.7, the test size 0.3. and it must be equals to 1. By using we just split the data by using the train test split method, and then we have to test the data by taking the input, and then after predicting the final output, the model will be saved, dumped into the model.pickle file by using the job lib. And then we have to create a Flask application file. Here the forestfire.html file is template is rendered, and then the model will be loaded by using the job lib into the file. And also here the loads here this file sets up a web application using Flask to create a user interface for the forest fire prediction model. It allows users to input data through a web form and receives prediction based on the trained model. Loads a pre-trained model. Example, using model.pickle using joblib, defines rules for the homepage and prediction endpoint. So these are the points that we have to discuss. And now let's discuss about the results. And these are the results. First, case 1. In this case, temperature and oxygen values dominate. Humidity values, the values of 45, 40, 20. Temperature and oxygen are good conductors, fire but not humidity. So in this case, model predicts that forest is in danger and the probability of fire occurrence is 1. And in this case, humidity dominates temperature and oxygen. The values are 10, 20, 70. Temperature and oxygen are good conductors, fire but not humidity. So in this case, the model predicts that the forest is not in danger. So here in this case, humidity dominates temperature and oxygen. The values of 45, 60, 70. Though humidity dominates, but temperature and oxygen make balance. So in this case, model predicts that the forest is in danger. The probability of fire occurrence is 1. Now let's discuss how we are running this project. Open the command prompt and then mount the folder called virtual environment, that is env, and then mount scripts, and then activate this too, and then undo the mounting of scripts and also env. Then use the command called flask run and run the program. Now click this link, click this above link. The web page will be opened in such a way. Now give the inputs called 40, 30, 80. So as we discussed, the forest isn't safe. So here, when the probability of fire occurrence is greater than 0.5, the forest is in danger. But here the probability of fire occurrence is 0.15. So here the forest is safe. In such a way, as we discussed about the results, this is how the model works. And thank you.